Hello friends, welcome to my channel. This is Vibration Part 3 Isro question paper. Question is, oscillation of a particle is prescribed by the equation x is equal to 3 cos 0.25 pi t, where t is the time in seconds, then time taken by the particle to move from position of equilibrium to maximum displacement is how much? Your equation is 0.5 is 1 by 4, so pi by 4 into t, and our displacement maximum is 3. At that case, cos pi by 4 t equal to 1 or cos pi, so pi by 4 into t equal to pi, t equal to 4 seconds. Position of equilibrium is when x is equal to 0. So 0 equal to, our equation is 3 cos pi by 4 t. In this case, it's cos 90 degrees or cos pi by 4 to t, so pi by 2 equal to pi by 4 to t, t equal to 2 seconds. At position x equal to 0, x equal to 0, at that time is 2 seconds. X maximum equal to 3, at that time t equal to 4 seconds. So time taken by the particle to move from x is equal to 0 to x is equal to 3 is our required time. Four seconds minus 2 seconds, it's 2 seconds. This is our required time. So C is our answer. Speed of particle executing simple harmonic motion with amplitude A is half of the maximum speed. At that instant, displacement of the particle is how much? SHM equation we will write first. Displacement x is equal to a sin omega t. Velocity x dot is a omega cos omega t. Here maximum displacement they asked. Here given in this question, a omega by 2 equal to a omega cos omega t. Omega cancel, 1 by 2 equal to cos omega t. 1 by 2 is cos 60 degree, cos pi by 3 equal to cos omega t. So omega t is pi by 3. Put the value of omega t in displacement equation. A into sin pi by 3. So sin 60 degree is root 3 by 2. A into root 3 by 2. Displacement x equal to a root 3 by 2. Here in this question, amplitude given as small a. So x equal to small a root 3 by 2. This is our answer. From option B is our answer. For two springs having same stiffness K are in series, the equivalent stiffness would be how much? We know equivalent for series connection, it's K1 into K2. Already this one discussed. Series and parallel connection. This one asked in our question. So both are same. So K1, K2 same. K into K by K plus K. K into K by 2K. K cancel. It's K by 2. So B is our answer. In simple harmonic motion, the acceleration is proportional to dash. A displacement, B linear velocity, C angular velocity, D rate of change of angular velocity. SHM equation again we will write. For displacement only x, A sin omega t. For velocity, first derivative x dot is A omega cos omega t. Then x double dot for acceleration, double derivative of x. It's minus A omega square sin omega t, or minus omega square into A sin omega t is our x displacement. So x dot is our acceleration, A equal to minus omega square into x. X is our displacement. So A is proportional to x displacement. A is our answer. A vibrometer, A indicates vibration amplitude, B indicates vibration frequency, C indicates nature of vibrations, D only indicates second and above harmonics. Vibrometer indicates vibration amplitude. A is our answer. A node of the shaft. At node of the shaft, A vibrations are minimum, the vibrations are maximum, the vibrations are average, the vibrations are 0. D is our answer. Vibrations are 0 at node. Whirling speed of a shaft coincides with the natural frequency of, this one already discussed, it's transverse vibration. Whirling speed of shaft. Oscillation of a particle is prescribed by equation x equal to 3 cos 0.25 pi t, where t is the time in seconds, the time taken by the particle to move from position of equilibrium to maximum displacement. This one already discussed. So directly I am solving this. Here 0.25 is 4, 1 by 4. So we write displacement equation x equal to 3 cos pi by 4 t. Maximum displacement equal to amplitude equal to 3. So we will write 3 equal to 3 cos pi by 4 t. 3 cancel. Cos pi by 4 t equal to 1 equal to cos pi. So pi by 4 t is pi. So from here t equal to 4 for maximum displacement. X is maximum. At equilibrium position x is equal to 0, displacement is 0, so 0 equal to 3 cos pi by 4 pi t. So cos 90 is 0, so cos pi by 2 equal to 3 cos pi t by 4. So pi by 2 equal to pi by 4 into t. This is 2. So t equal to 2 seconds. This one also second. at x equal to 0. So in this question they ask time taken from particle to move from position of equilibrium or x equal to 0 to maximum displacement, x equal to maximum. So this one already discussed. Time required is 4 minus 2, that's 2 seconds. A is our answer. Two heavy rotating masses are connected by shafts of length L1, L2 and L3, and the corresponding diameters are D1, D2 and D3. This system is reduced to a torsionally equivalent length of shaft is option A. Option A is our answer. A machine mounted on a single coil spring has a period of free vibration of T, capital T, if the spring is cut into 4 equal parts and placed in parallel and the machine is mounted on them, then the period of free vibration of the new system will be how much? Spring first K, stiffness cut into 4 parts. So we will use this formula. G d to the power 4 by 64 RQN, cut into 4 parts. It's n by 4, so K1 is 4 into G d to the power 4, 64 RQN. So it's equal to 4 into K. It is the stiffness of one single spring after the cut. So then they are placed in parallel. So K equivalent is K1 plus K1 plus K1 plus K1. 4 springs having stiffness 4 times of the single coil spring. So 4 into 4K, it's 16K. The stiffness is 16K. Then we have to calculate the period of free vibration. Omega n is K equivalent by M. Then frequency is 1 by 2 pi K equivalent by M, and our time period is 2 pi into root over of M by K equivalent. Initially capital T is our time period, 2 pi M by K. Then finally T dash is 2 pi after cut. Mass is same. K become K equivalent is 16K. This one I got already, 16K. So it's 2 pi 16 root over is 4 whole into root over of M by K. So it's 1 by 4 into 2 pi whole root over M by K is T. So it's T by 4. B is our answer. Four linear elastic springs are connected to mass M as shown in figure. The natural frequency of the system. First it's in parallel case, then series case. First the upper 3 springs, they are in parallel, so for upper 3 springs we will do in this case K equivalent equal to all are K. So K plus K plus K is 3K. then you make it as single spring having 3k stiffness, then one spring with k stiffness, then mass capital M. We have to calculate here k equivalent equal to, this is series connection, so 3k into k, 3k plus k, we'll get 3k into k by 4k, k cancel, 3 by 4k. We have to calculate natural frequency of the system, Fn we have to calculate. It's Fn equal to omega n by 2 pi. So omega n is k equivalent, root over of k equivalent by m. 1 by 2 pi root over of k equivalent is 3 by 4 k divided by mass m. So from option we have to check. D is our answer. Root over of 3k by 4m divided by into 1 by 2 pi. D is our answer. In the viscous damped vibration, the logarithmic decrement value over 5 cycles is found to be 8.11. What is viscous damping factor of vibration system? Vibratory damping factor is zeta, we have to calculate. Logarithmic decrement given, logarithmic decrement over 5 cycles, so it's log x1 by x6. After 5 cycles, x6 will be our amplitude, it's 8.11. and delta we know, it's log x1 by x2. So we know x1 by x2 equal to x2 by x3 equal to x3 by x4 equal to x4 by x5, x5 by x6 over 5 cycles. 1, 2, 3, 4, 5 cycles. So from here we'll write log x1 by x6 equal to log x1 by x2 into x2 by x3 into x3 by x4 into x4 by x5 into x5 by x6. Same. So we can write it as x1 by x2 to the power 5. It is 5 log x1 by x2, same value. Log x1 by x6 already given, it's 8.11. So from here we will get log x1 by x2 or delta equal to 8.11 by 5. So it will come 5 into 1, it's 5 point, then 6 to 5, and next delta equal to 1.625. We know logarithmic decrement delta equal to 2 pi zeta by 1 minus zeta square root over. This is very important formula. So many times asked in GATE examination. So we already got delta value. So delta value we will put here This is only calculation left. Square, we'll take this one. Squaring both sides, this is 1.625 whole square 1 minus zeta square equal to, this is 2 pi square into zeta square. So 0.625 square minus 0.625 square into zeta square equal 2 pi square into zeta square. No need to square this one, you just put as it is. Then 1.625 square, take this one right side, we'll get zeta square common, 2 pi square, here 2 pi square plus 1.625 square, it will come around 42. So zeta square is 1.625 square divided by 42. So zeta is 625 square divided by 42 root over. 16 square is 256. So it will come around 2.6 by 42 root over 2.6. Here multiply 10, this is 26. So 13 into 2, 13 into 3. So it's 2 by 30. So it's 1 by 15 root over. 1 by 15 is, so it's 0.0, then 100, 100, 15 into 6, then 10, 100, 0.066 root over 0.066 root over. So here it's very difficult to get 0.066 root over. So from option we have to see, it's around 625. 625 means it's 25 square. So it's nearly 0.25. Yes, 0.25 square is 0.0625. So zeta value, I got this. With that calculator it's little bit difficult, but we can do it. So from option it's in percent, so 0.25 equal to 25%. So from option B is our answer. Thank you friends for watching my video. Thank you.